Let's review this entire module now with some practice problems. So in question 1, we're looking at the ages of different patients in a hospital system throughout the year. Part A says, what is the probability that a patient is between 18 and 44 years old? And so the fundamental counting principle says, let's just take the total number of patients that we have between 18 and 44 and divide by our grand total number of patients. And so the total number of patients that we have between 18 and 44 is 79,659, and we're going to divide that by 409,706. So I'm going to enter this in the calculator, 79,659 divided by 409,706. And I get an answer of 0.1944, and that's if I'm rounding to 4 decimal places. So about a 19% chance that a patient is between 18 and 44. Part B, what is the probability that a patient is 65 or older? So again, the counting principle says, let's add up the total number of patients that are 65 or older. That's everything that we have here, 65 to 84 and 85 and up. We're going to add this up, and then we're going to divide by our grand total. So let's do 80,649 plus 16,764 and divide by our total of 409,706 patients. And so if you're entering this into the calculator all at once, like I'm about to, make sure to use parentheses, 80,649 plus 16,764 divided by 409,706. We get an answer this time, 0.2378, and that is if you're rounding to 4 decimal places. Okay, let's go to part C. It says, using a cutoff of 0.05, is it unusual for a patient to be less than 1 year old? So let's find the probability that a patient is less than 1 year old. And if that probability is less than 0.05, then it is unusual. So the number of patients that we have that are less than 1 year old is 7,866. So I can take that, divide by my grand total of 409,706, and let's see what number we get. 7,866. Oops, got an extra 6 there. Divided by 409,706 gives us 0.0192, and that is if you're rounding to 4 decimal places. And this is less than 0.05. This is 1.9%. And so we would say, yes, this is unusual. Okay, let's take a look at the next question. This next one involves the concept of the probability of one thing or another. So it says, Bluefly.com, an online designer clothing marketplace, purchases items from Kenneth Cole, Michael Kors, and Vera Wang. The most recent purchases are shown here. So we've got it all listed in the table. And then the question is, if one item is selected at random, let's find these following probabilities. First, let's find the probability that it was purchased from Kenneth Cole or is a dress. So like I said, this is going to involve the probability of one thing or another. And we saw in the earlier videos that there is a formula for doing the probability of one thing or another, but we also saw that you can reason through a lot of these problems, especially when you're given a table. And I'm going to show you that reasoning approach right here. So let's go through this table cell by cell right now and circle each cell that represents a number of items that are purchased from Kenneth Cole or a number of items that are dresses. So if we begin right here with this 24, I'm going to definitely be circling this because these 24 items are purchased from Kenneth Cole and they are dresses. These 13 items are purchased from Kenneth Cole, so let's circle this. These 18 items, they're not purchased from Kenneth Cole, but they are dresses, so I'm going to circle that. These 36 items, they're not purchased from Kenneth Cole and they're not dresses, so I'm not circling that. These 12 items, they're not purchased from Kenneth Cole, but again, they are dresses, so we should circle that. And then these 15 items, they are not purchased from Kenneth Cole and they are also not dresses, so I'm not circling that. So to find the probability that an item selected at random is purchased from Kenneth Cole or his address, we take the total of items that are purchased from Kenneth Cole or that are addresses, and we are going to divide that number by our grand total of all of the items. So the total number of items that are purchased from Kenneth Cole or that are addresses is the sum of the numbers that we've circled. So our numerator is 24 plus 13 plus 18 plus 12. And our denominator is the sum of all of the cells. And so that's going to be 24 plus 13 plus 18 plus 12. And then you can see that we additionally have 36 and 15 in that denominator. So let's compute this. Over here we've got 24 plus 13 plus 18 plus 12. And that gives me a numerator of 67. And our denominator is going to be all of that with an additional 36 and 15. So let's say 16 or 67 plus 36 plus 15. And so that denominator is 118. So you should end up with 67 divided by 118 for your answer here. And this gives us, rounded to 4 decimal places, 0.5678. Okay, now I'm going to erase this table, and I'm going to start from scratch to answer the next OR question. Okay, so let me get rid of what I circled before. And this time we're saying, what's the probability that it is a pair of jeans or it was purchased from Kenneth Cole? So again, let's go cell by cell, and we'll circle the cell if it represents a number of items that are jeans or if those items were purchased from Kenneth Cole. So we can see that we're going to be circling everything in this column again because it's purchased from Kenneth Cole. But then we only want to circle the other cells that represent items that are jeans. And it's not going to be this cell right here because this isn't purchased from Kenneth Cole and it's not jeans. But these 36 right here, these 36 items, yes, they are jeans. And these 15 items represent a number of jeans. And so to answer this question, we would say, okay, let's get the grand total of all jeans as well as items purchased from Kenneth Cole. And so we can get that grand total by saying 24 plus 13 plus 36 plus 15. And we'll divide by the sum of all of the cells. And the sum of all of the cells was 118. And so this time, let's see what our numerator is. 24 plus 13 plus 36 plus 15. And we get an answer of 88 out of 118. So 88 divided by 118 gives us a decimal this time of 0.7458. Okay, so again, as you've seen earlier in this module, the OR questions can many times be answered based upon reasoning and using strategies very similar to the one I just did. Okay, let's go to the next example. In example 3, we've got a table of the number of men and women with various levels of education. Now, just to be clear, when you look at this table, these headings represent the highest level of education. And so let's keep that in mind as we look at the example now. So it says a person is selected at random from the population in the table. What is the probability that the person is a woman, given, there's that word that we've seen a number of times, given that the person is a high school graduate? So given that high school is the highest level of education. And so as we've seen earlier in this module, whatever is after the word given is exactly what we want to subset our table to be. And so let's take the original table and instead of looking at the entire thing, say, well, hey, we're just looking at when the person's a high school graduate. So we're just looking at this column right here. So when we're just looking at this, given that the person's a high school graduate, the probability that the person's a woman would be 31.9 out of 29.6 plus 31.9. So out of the total number of people where high school is their highest level of education. So let's compute this. 31.9 divided by parentheses 29.6 plus 31.9. We end up getting an answer of 0.5187. 0.5187. So the key thing to remember here is whatever is after that word given is exactly what you subset your table to, and then you work with that subsetted data to answer your probability question. Okay, one final question here. In a certain city, 70% of high school students graduate. Of those who graduate, 40% attend college. So that speaks to a conditional probability, right? It's saying that given that a student graduates, there's a 40% chance that they will attend college. So keep that in mind. Let's find the probability that a randomly selected high school student will attend college. So I want you to recognize that if a randomly selected high school student is attending college, then that means they are graduating high school and then they're also going to attend college after that. So we're looking at the probability of a sequence of events. And so specifically, we're looking at the probability of graduating high school and then attending college. And again, that's conditional on the fact that they graduated high school. Okay, so in order to approach this, we know we can rely on the formula. We can also reason through this. We can use the tree diagram as we've seen in an earlier video. But I think this is one where the formula is definitely a good one to keep in mind. It's a pretty simple one, and we know that all we need to do is take the probability that that randomly selected student would graduate high school and multiply by the probability of attending college given that they graduated high school. And we are given both of these probabilities in the question, and so we can simply take our 70% likelihood of a student graduating high school and multiply that by the 40% likelihood of that student attending college given that they graduated high school. And if you go over to the calculator and do 0.7 multiplied by 0.4, you end up getting 0.28 or 28% as the probability that a randomly selected student in this particular school district would attend college. Okay, so I hope this helped looking at a recap of some of these major themes in this module, but it's going to take a lot of practice. So work at this, ask a lot of questions, and eventually you'll be a lot more comfortable with these fundamentals of probability.